Good day, this is General Mathematics 1, MTH 101. I'll be taking you through study section 10, gradient of a line. Learning outcomes for study section 10. When you have studied this section, you should be able to state the formula of the gradient of a line. Secondly, you should be able to define collinear lines. You should be able to state the conditions under which two lines are parallel. And similarly, you should be able to state the condition under which two lines are perpendicular. And lastly, you should be able to apply mathematical operations on parallel lines. What is a gradient? The gradient of a line, which is also called a slope, can be defined as the angle which the line makes with the horizontal. In other words, we can define the gradient of a line as the vertical distance traveled per horizontal distance. Let's consider a line AB which passes through a given point, which are points A and B. Let's say this is a given axis, where this axis is the y-axis, while this is your x-axis. Let's consider a line AB, and at a point at which the vertical line touches this line AB, will give us a certain point, and another point where this line touches line AB will give another point, and which forms a right angle triangle over here, angle theta. At a point where, let's call this y1 and y2, y we call this x1 and x2. At a point where the y-axis meets the x-axis, let's call it A. At a point where the y-axis meets another x-axis, tracing it from the horizontal line, let it be called B, and let this space be called C. Now, at this point, which is point A, you have your x1, y1. And at this point upper, you have your x2, y2. And if you look at your horizontal line, the difference between the first portion of your x-axis to the second, which is the change in x, will give you x1, x2 minus x1. While that of y-axis will give you y2 minus y1. Now, how do we now determine our gradient? The gradient of this line AB. This is how we are going to come about it. You know, if you go back to the previous study sections, we were told that for you to obtain your tan theta, you know that your tan theta is equal to opposites over adjacent, which is your TOA, out of SOHCAHTOA. Now, if you want to use this expression in order to get the gradient of this line AB, it means that your tan theta will give you your opposite side, which is your y2 minus y1 over adjacent. Your adjacent is your x2 minus x1. In other words, you can say therefore we come about an expression that gives you tan theta is equal to change in your y-axis over change in x-axis, because y2 minus 1 gives us the change in y-axis is equal to y2 minus y1, while change in x is x2 minus x1. Now substituting this into the formula, as you can see, tan theta is equal to change in y over change in x. Therefore, you come to the final expression where m represents your gradient. M is equal to tan theta, which is equal to y2 minus y1 all over x2 minus x1. So this is your expression for the gradient of line AB. So let's go back to our slide. Now, that was how we came across this expression, gradient M is equal to y2 minus y1 over x2 minus x1, which is equal to tan theta. So from this expression, you can obtain your theta by making theta the subject of the formula. Now let's consider an example where we are asked to calculate the gradient of the line joining the point 6,5 to minus 3, minus 2. Now considering these 2 points, let's call this one point A, while we call this point B. From these 2 points, you should be able to obtain your x1, y1, x2, and y2. From these 2 points, your x1 is 6, your y1 is 5, while your x2 is minus 3, and your y2 is equal to minus 2. Now, if you recall the formula we used the other time, that gradient of a line is equal to y2 minus y1 divided by x2 minus x1. All you need to do is to substitute for these values into your formula. And do not forget that this is also equals to tan theta. So that is the expression. So substituting this formula, you have your y2 to be minus 2 minus, don't be confused with the sign. What is your y1? Your y1 is 5 all over what is x2 minus 3 minus what is x1? X1 is 6. This is very simple. Make sure that you are not confused with these signs. And simple board maths will be able to do that. So our m now will be minus 2 minus 5 all over minus 3 minus 6, which will give us minus 7 over minus 9. And at the end of the day, you get your gradients to be 7 over 9. That's your answer. Let's go back to our slide. And that was how we obtained 7 over 9. It means that the gradient of this line, of this point, 6,5 to minus 3,2 is 7 over 9. And as I said earlier on, you can go ahead and put your obtain your tan theta from the equation. Let's consider an example where you have 2 points, 4 and minus 3, minus 5 and minus 7. But in this question, you are asked to calculate the angle which makes with the positive x-axis. As you can see from the slide, all you need to do is to obtain your gradient. After obtaining your gradient, you obtain your tan theta. Let us work it out and see. So let's see how we can obtain the angle which these lines make with the horizontal, which is the x-axis. As we did in the former problem, 4 will be the x1, this will be the y1, this will be the x2 and the y2. Applying our formula, which is change in y over change in x, and it's equal to 1 minus 2 over y minus 1 over x minus 2 over x minus 1, x1. So you can obtain your gradients to be y2 minus y1, that is minus 7 So you obtain your m to be minus 7 plus 3, giving you minus 4 all over minus 5 minus 9, giving minus 5 minus 4, giving minus 9, which is equal to 4 over 9. Do not forget that we said the other time that our gradient is also equal to m times theta. From this expression, since our gradient is equal to tan theta, which is equal to 4 over 9, we can now obtain the value of our angle, which is theta, by making theta the subject of the formula. So theta will be equals to tan inverse bracket 4 over 9. And from that you can obtain the value for your theta. Let's go back to our slide. And that was how we were able to obtain our expression for theta, which is 23.96 degrees. What about collinear points? Collinear point exists when the gradients between two adjacent pairs of points are equal. It means that if you have about 3 or 2 points, when after you have obtained their different respective gradients, if they have the same value, it means that those points are collinear. Assuming 3 or 2 or more points are collinear, it means that they lie on the same straight line, which has a constant gradient, that is m1 is equal to m2, is equal to m3, is equal to m4, and so on as many as the points you were given. This is an example for us to obtain the gradient of this following point and to see whether they are collinear or not. At the end of the day, if they are collinear, then points A, B, AC, and BC will have the same gradient, the same value for their respective gradient point. But let's see now, let's calculate and see if these 3 points A, B, C have the same gradient value. Now, in such a case, all you need to do is to find the gradient of point A to B, and that was how we obtained 2 for the gradient of A to B. Secondly, you find the gradient from B to C, and we discovered that the gradient gave us the value of 2 as the first point A to B. And thirdly, we calculated another the last point, which is A to C, and we discovered that we had the same value for the 2 for the 3 points. It means that gradient A to B, B to C, and A to C are collinear, since we obtained the value of 2 for these 3 points. We can also go ahead to obtain an equation for gradient AD, and that was why we used the equation that was given to us in the question to find our x1, y1, but in this case it's a 1-point gradient, so we use another formula in order to obtain that. Now for the second subsection, we have to find the value of x. If this point D has the same gradient, which means it's collinear with point A2. How do we obtain that? Recall that for our gradient M, our formula is y2 minus y1 over x2 minus x1. And from these 2 points, we can obtain our x1, y1, and x2 and y2. We have gotten from the previous solution that our m is 2, and being collinear, it means that this point has 2 values for its gradients too. So substituting m, we have 2 is equal to y2, these are x1, y1, x2, y2. So for our y2, we have 5 minus y1, which is 2x, all over x2 is 2, yx1 is 3x. So we can make x a subject of formula here to obtain an expression for x, which is equal to if you do cross multiplication, you obtain 4x minus 6 is equal to 5 minus 2x. So from this expression, you can obtain the value for x. Let's continue. And that was how we were able to get minus 1 over 4 for the value of x. What about parallel lines? Considering two lines, N1 and N2, if N1 and N2 denote the gradients of lines M1 and N2, if after obtaining the gradient for the first line and the second line, we're able to obtain the same value for the first line and the second line, then we can say that the lines are parallel, and we can conclude that two lines are parallel if only they have the same gradients. Let's see this example. Find the equation of the line parallel to the line 3x plus 2y is equal to 8 through 4, minus 3. The first thing is for you to obtain your value of the gradients from the equation you are given, and that was how we were able to come to a number for the gradient for the equation, which is minus 3 over 2. After that, you make use of the formula for 1 pound, because for if you want to obtain the gradient for a 1 point for where the line is concerned, you use equation y minus y1 is equal to n into bracket x minus x1. And when you substitute all these values into this equation, you'll be able to derive an expression for the equation of the line, of the required line, which is y plus 3 is equal to minus 3 over 2 into bracket x minus 4. At the end of the day, if you make use of some simple algebraic equation, you'll be able to come to a point where you have 2y plus 3x is equal to 6. Thanks for listening.